solving some complicated projectile problems with a protractor and a ruler. Let's learn physics. Projectiles. The problems we solve are based generally on the fact that this ball is acting differently in the horizontal and the vertical. Because there's only, as this thing flies through the air, there's only one force acting down on it. We're assuming no air friction. That thing is going to accelerate in the vertical direction and basically just roll along in the horizontal direction. So it's a combination of two. These problems turn out to be difficult because we have to use trigonometry generally to find the components of the vectors. And then as this thing flies through the air, you want to find out where it lands, you want to find the final velocity, you want to find all these different things. And it takes a while. And we don't do this kind of problem generally with the lower level students. And some of the honor students really have a lot of difficulty with it. We're a bunch of nerds and we like math. Here's the problem in diagram form. You have a 60 meter per second velocity 40 degrees above the horizontal. And at those various green arrows, those different times, find the final velocity, the new velocity, speed with direction. So we set up a chart, an X and Y chart, because this thing acts differently in the two different directions. And take that 60 meters per second, split it into its two components, 60 cosine 40, 60 sine 40, to give you 46 and 38.6 meters per second. And take that 46 and put it in the X column. It's the constant X velocity. And then don't touch that. And then take that 38.6 and put it in the Y direction. And that thing's going to change. So you have a Vx doesn't change, and the VIY, which does change. And so there's an initial and a final. And the acceleration in the Y direction is -10. The acceleration in the X direction is 0. And then for these different times, I want to find that different velocity. So here's the process we normally use. Vf is equal to Vi plus At. Basic equation applied in the Y direction at 5 seconds. 5 seconds of those 4, I picked 5. At 5 seconds, it's negative 11.4 meters per second, or 11.4 meters per second down. Then you have to make another triangle like that one, but like this one, because you now still have that constant 46 meters per second in combination with the negative 11.4 meters per second. That is your new velocity. It's past the peak, it's coming down, and here you go. What you have to do, and this is all mathematical, and I know I've lost most of you by now, but stick with me or just fast forward to the conclusion. Find the hypotenuse using the Pythagorean theorem to get 47.4 meters per second. Inverse tangent of 11.4, the opposite over the adjacent 46, 13.9 degrees. So the answer is 47.4 meters per second at 13.9 degrees below the horizontal. And that is why, even in the honors class, we often don't solve this problem much, if at all. It's complicated, it's long, it requires you splitting components and putting components back together. And, yeah. Was there an easier way? Oh, check this out. See that? That's the solution for 4 final velocities, the time to the top and the time till it hits 80 meters per second. Nice. If you have a projectile like that ball that you have a projectile like this, you want to find the velocity of that ball at any particular time. You can do this without any trigonometry and without splitting it into its X and Y components at all. It's actually a pretty sweet method. It's based on the final velocity is equal to the initial velocity plus acceleration times time. It's a pretty simple equation. It's a vector equation. And we can represent that with a protractor and a ruler and solve the problems that way. It's slick, it's fast, you get lots of different solutions really, really quickly. You're not touching lots of calculators, you're multiplying by 10. Here, check it out. And I've never seen the problem solved this way before. Rather than forcing students to learn algebra that they're bad at anyway, let's solve that same problem and a bunch more using a protractor and a ruler. Same setup, 60 meters per second at 40 degrees. Supposed to find the velocity at 1 second, 3 seconds, 5 seconds, and 8 seconds. We're using this equation, but we're using it in the two-dimensional vector version of that equation. The final velocity is initial velocity plus acceleration times time. And remember, that is acceleration of 10 meters per second every second down. Bigger diagrams will give you better results. And I want to make sure that I plan to get this thing on. So I'm going to make this thing 12 centimeters long at 40 degrees to represent the 60 meters per second at 40 degrees. So it looks like it's going to fit. I can start right here at this point. Make sure you're standing over it also and lining up all these lines to make sure everything is perfectly lined up. Mark very carefully at that 40 degree mark. And then using a 2-to-1 scale, make this thing for 60 meters per second. I'm going to make that 12 centimeters long. Now the acceleration times time. Time is a scalar and the acceleration is down toward the bottom of the page. So all I have to do now is take the end of this, use a different color for the acceleration, and draw a line straight down toward the bottom of the page representing acceleration times time. This is the acceleration times time line, which has a lot of different lengths, and we're going to mark it off now. Now, since 10 meters per second is equal to 2 centimeters, I know that 10 meters per second every second for 1 second is going to be 10 meters per second. So here's the idea. You have 60 meters per second minus 10 meters per second in the vertical direction for 1 second, minus 30 meters per second in the vertical direction for 3 seconds, minus 50, minus 80. And so the first one, I'm just going to measure down, straight down, for 1 second, 2 centimeters. And that's right there. Just put a mark. And then for the next one, doing 3 seconds, 3 times 2 is 6. Measure down 6 centimeters, mark. Measure down 10 centimeters, mark. Measure down 16 centimeters, mark. Now all I have to do to find the final velocity for every one of these is connect the final velocity. This is the acceleration times time. So initial velocity is this, 12 centimeter. The acceleration times time is that little vector right there. Next one, 3 seconds at 5 seconds, 8 seconds. This is at 1 second, at 3 seconds, initial velocity plus a times t. At 5 seconds, initial velocity plus a times t. 8 seconds, initial velocity plus a times t. Now all I have to do is measure those four. 10.8 centimeters long, 54 meters per second. So that's how fast it's going. That's the speed. The next one, 94, it's 47. About 95, about 47 and a half.
You're going to get 47.4 meters per second.
12.4 is 62. Now the velocities, all you have to do, put your protractor on here and measure those. And above the horizontal and below the horizontal. Line everything up really carefully as you did before. Here, here, and here. First one's 40 degrees. Second one is 32 degrees. 32 degrees. This one is 11 degrees below the horizontal. 13.5 degrees.
13.9 degrees. So the answer is 47.4 meters per second at 13.9 degrees below the horizontal.
32 degrees. There's an answer, there's an answer, there's an answer, there's an answer. That's 4 solutions, and if you want to draw lines, there are a lot more there. How long does it take to get to the top, the very peak of that motion? Well, I'm glad you asked. Here's a quick solution. You know that at the top there is no vertical velocity, it's all horizontal, so draw that final velocity right there. You have the initial velocity at the top arrow, and then the final velocity is there, and so just measure that vertical and divide by 10 meters per second every second to find the time. 3.9 seconds, which corresponds exactly with, well, look at that, 38.6 meters per second, would take about 3.9 seconds to get to the top. You want to find the time that it'll take to go 80 meters per second? Because eventually it'll go faster and go 80 meters per second. That's 16 centimeters. There, it's 80 meters per second, 16 centimeters long. Bonus solution,
That's 55 degrees below the horizontal.
The total time that takes. So that's 16. We measured that before. And 16 plus 4.7, 20.7, which is 10.4 seconds. So after 10.4 seconds, this ball will have, if it has enough room to fall, will be traveling 80 meters per second at 52 degrees below the horizontal. I mean, this technique is powerful for certain things. If you're looking for final velocities, or if you want to find times, this is a replacement for complicated algebra for various types of projectile motion problems. We're a bunch of nerds and we like math. I've never seen the problem solved this way before. I don't know where I came up with it. You can do a lot of things, and it's based on an algebraic equation that is a vectorial equation that can be represented on a piece of graph paper. And if you can solve it this way, and solve for a lot of really good things this way, solve for time, solve for final velocity, solve for some really good stuff, then why not use it instead of the algebra method, rather than forcing students to learn algebra that they're bad at anyway? I mean, you could, but I have not found that to be highly successful, and I found it to be highly frustrating because I'm teaching physics. I'm not teaching math. This method is really good. So try it. Maybe it's just me, but I find it really satisfying to solve some of these really tough projectile motion problems with just that protractor and ruler. Thanks for watching Learn Physics, and thanks for that thumbs up too. Really helps a lot. New videos most academic weeks. Subscribe for more. I've even got education ideas, Freaky Physics Friday, and Tech Tip Tuesday. And for bicycles, motorcycles, and family adventures, it's my other channel, Bike Physics. You just learned physics.